चलो. So we are finite wire ka. We are taking the some more numericals. Okay. Using Biot-Savart's law to obtain expression for magnetic field at the center of a coil bent in the form of a side to a current carrying wire I. The square coil is there, current is flowing I, and the side is 2A. I want magnetic field at the center of the coil. Okay. Here, how many wires are there? Straight wires are there. How many straight wires are there? 1, 2, 3, 4. 4 wires are there. Okay. मतलब magnetic field will be there because of these 4 current carrying wires. So पहले एक फाइंड करेंगे इसका. देखो इस वायर है. I'll join starting point. I'll join ending point. And this is a perpendicular distance. This perpendicular distance is how much? This perpendicular distance. This total is 2A. This will be A. Right? Now, इसका angle चाहिए. 5 1 5 2 चाहिए. Then only I can find the magnetic field at this point O, right? So 5 1 5 2. 5 1 is how much? 5 2 is how much? This is perpendicular. 90 ka half is 45. Therefore, this also 45. Similarly, this is 90, 45. 5 5 2 is also 45. See, angle we should take from perpendicular distance only. Perpendicular distance to the ending point, perpendicular distance to the starting point angle. Now, net resultant will be magnetic field at O. B1 plus B2 plus B3 plus B4. Since it is vector quantity, direction check करने का. Whether addition or subtraction we don't know, right? How to tackle? देखो. Thumb indicate direction of current and curled fingers indicate direction of magnetic field. So inverse है. इसके वजह से inverse है. इसके वजह से inverse है. And उसके वजह से inverse है. In all direction inverse है. That's why we are adding B1 plus B2 plus B3. If any one conductor is ulta means minus you have to put. Okay. Right hand thumb rule. Now find karo. Since all distances are same, all things are same. If you get one magnetic field into 4 किया तो आ जाएगा आंसर.
So
So B1 find करो.
not by
Mu naught
I
divided by बोलो.
I by A
Yes. So mu naught by 4 pi into I by A into sin pi 1 plus sin pi 2. Sin 45 plus sin 45. So कितना 1 by root 2, 2 by root 2. So root 2, right? So B1 will get as mu naught by 4 pi into I by A into, so 2 by root 2 means root 2, right? Root 2. This is for one magnetic field. Since every current carrying wire ka magnetic field is inverse, that's why we are adding. Since distances and everything is same, that's why net magnetic field is 4 times of B1. So nothing but 4 root 2 mu naught by 4 pi into I by A. I'm trying to keep in all numericals में mu naught by 4 pi ऐसे ही, so that if the numbers are given directly you can substitute 10 power minus 7. Okay. So direction check करके we have to find the net magnetic field. We learned till now the finite current carrying wire के वजह से we learned the magnetic field. Okay. Copied. Next. Hello. This is JEE question. Magnitude of magnetic field at the center of the equilateral triangle loop of side 1 meter. So side है 1 meter. This is the equilateral triangle. I want to find the magnetic field at this point center में वो, which is carrying a current of 10 amperes. इसमें current 10 amperes, 10 amperes, 10 amperes. So here 3 conductors are there. Try करो देखते हैं. there are 3 wires. Each one ka, if you see, thumb indicate direction of current, curl fingers indicate direction of magnetic field. Magnetic field inverse. इसके वजह से also magnetic field inverse. So all magnetic field is inverse. एक का magnetic field find करने के बाद into 3 करने का. Satvik, 5152 कितना आया है ना? If I take this current carrying wire, if I draw one perpendicular, this starting point join करो, ending point join करो. Okay. हाँ
60.
60. So 90 है, a 60 है ना equivalent triangle, this is 30. So definitely 5152 60. Okay. तो perpendicular distance कितना आएगा?
1/2.
1/2. No wrong. This distance I want. This a value I want.
So 2/√3 is distance.
2/√3, no? A value how much you got?
So root 3.
Huh?
Sir, A is root 3 by 2.
√3/2, no wrong. Why √3/2? Tell me.
With
देखो, whenever right angle triangle is there, use trigonometry. This is how much? आधा का ना? Total is 1 meter, right? So this is 1/2. So tan 30 is equal to opposite by adjacent 1/2. So it is tan that is 1/√3 is equal to a. उल्टा है तो 2a, right? So a is equal to 1/2√3. Substitute this in the formula में. So first connector I am trying to find, B1 I am trying to find, mu naught by 4 pi.
18.
Huh?
18.
Uh, I by a. So 10 by a is 1/2√3 into sin 51 plus sin 6. Sin 60 plus sin 60 is √3/2 plus √3/2. 2√3/2. Right? So √3. So उल्टा क्या था, क्या होगा? B1 is 10 power of -7 into 2√3 into √3 into 10. So 3, 6. B1 is 6 into 10 power of -6 Tesla. Now क्या है? Since the direction is same, so therefore net magnetic field is into 3 करने का, 3 times of B1. So 18 into 10 power of minus 6 or 18 micro Tesla. Understood? That आपको whenever right angle triangle is there, you have to understand, okay, trigonometry use करेंगे बोल के, maths will be helpful in every step में. चलो. Now till now we learned about the finite current carrying wire के learn. Okay. Now we'll go for a infinite length का current carrying wire. Infinite current carrying wire. This is a finite current carrying wire, right? Now infinite means इस तरफ जाएगा infinity, A वाला भी infinity. इधर से A distance दूर में I want to find the magnetic field at this point P. Okay. Phi 1, phi 2 values can you tell me? If the conductor is stopping here, the phi 1 will be here. If the current is stopping there, phi 1 will is increasing. Phi 1 or phi 2 is increasing. Either if the conductor is stopping here, so phi is increasing, right? मैं करते 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 infinity में कितना होगा phi 1? How much will get phi 1 angle? See, before 90. And phi 2 same way infinity है ना, increase करके total 90 आ जाएगा. So substitute phi 1 is equal to phi 2 is equal to 90 degrees. So find the magnetic field. Mu naught by 4 pi into I by A into sin phi 1 plus sin phi 2. So sin 90 plus sin 90 is 2, right? So 2. So therefore net magnetic field for an infinite wire is mu naught by 4 pi into 2I by A is the formula. Mu naught by 4 pi into 2I by A is the formula for infinite wire. Okay, ये भी formula learn करना पड़ेगा. Okay, so first we are doing पूरा straight current carrying wires only. उसके बाद we have to go for circular wires. Okay, now for infinite semi-infinite wire, take up it, right? Now for semi-infinite wire करो. Semi-infinite means one side infinity and other side end हो जाएगा. Semi-infinite wire. इधर से A distance दूर में I want to find the magnetic field at this point P. Current carrying wire की वजह से. हाँ. Tell me इधर phi 1 कितना, phi 2 कितना? Phi 1 is how much, phi 2 is how much?
Phi 1 is 90 and phi 2 is 0.
हाँ. एक एंगल है, देखो it goes are increasing, other one is 0. Now substitute in the formula में B is equal to mu naught by 4 pi into I by A into sin phi 1 plus sin phi 2. So phi 1 is 0 हो जाएगा, phi 2 is 91. 1 into multiply किया तो B is equal to mu naught by 4 pi into I by A is answer. This is for semi-infinite wire. Finite बोले तो phi 1 phi 2 वाला आएगा. Infinite means 2I by A and semi-infinite means I by A वाला only. Mu naught by 4 pi into I by A. फॉर्मूला बैठ कर लास्ट. आ गया, श्रीराम आ गया. Infinite wire I want. Tell me, infinite current carrying wire की वजह से what is the magnetic field? Mu naught by 4 pi into
4 pi into I by A.
2I by A. 2I by A. That is for infinite wire. Infinite wire में 2I by A आएगा. Finite wire only sin phi 1 sin phi 2 आएगा. Okay. Tell me, Sanve, for semi-infinite wire,
Mu naught by 4 pi into I by A.
Satvik, for a finite current carrying wire,
Finite.
finite
That is mu naught by 4 pi I by A into sin phi 1 plus sin
plus
phi.
952. ये फॉर्मूलास आपको बहुत अच्छे से करके बैठ किया तो इट विल बी इजी फॉर यू. ओके, चलो. So two infinite current carrying wires are there with a current I1 है and current I2 है. These are infinite wires and they are placed perpendicular to each other. I want the net magnetic field at this point P. Magnetic field will be because of first wire also, because of second wire also. Infinite wire का फॉर्मूला यूज करके सॉल्व करने का. ओके, ट्राई. इधर से डिस्टेंस कितना है? ए डिस्टेंस है ना, बिकॉज ए कामा बी इज गिवन पॉइंट. दिस ए एक्स में एंड वाई में बी. Now try. I think you will do mistake.
So,
Tell.
so mod of mu naught by 2 pi into I1 by A minus I2 by B.
Oh, correct. Very good. देखो, दिस इनफाइनाइट वायर है, दो करंट कैरिंग वायर, फर्स्ट वायर सेकंड वायर. सो फर्स्ट वायर मैग्नेटिक फील्ड कितना होगा? म्यू नॉट बाई 4 पाई इंटू 2 I by A. 2 I1 by distance is A only, first one. B2 will be mu naught by 4 pi into 2 I2 by B. नेट मैग्नेटिक फील्ड आई वांट टू फाइंड. नेट मैग्नेटिक फील्ड के लिए आपको डायरेक्शन चेक करना पड़ेगा. देखो, फर्स्ट करंट कैरिंग वायर के वजह से इट इज इनवर्ट्स एंड सेकंड डायरेक्शन की वजह से देखो करंट थंब इंडिकेट डायरेक्शन ऑफ करंट एंड कर्ल्ड फिंगर्स इंडिकेट डायरेक्शन ऑफ मैग्नेटिक फील्ड इज आउटवर्ड्स. वन इज इनवर्ड्स, वन इज आउटवर्ड्स. सो नेट मैग्नेटिक फील्ड विल बी either B1 minus B2 or B2 minus B1. We don't know which one is higher, right? Bigger minus smaller करने का. That's why we are putting the magnitude. mod लगा रहे हैं, mod लगा के mu naught by 4 pi into 2 कॉमन लेके I1 by A minus I1 by B, I2 by B. Okay, so mod क्यों लगा रहे हैं? Because it can be anything. Values दिया तो we can know which one is smaller, which one is bigger बोल के. Okay, चलो next. JEE means question. Copy it, Sriram. Right. Same model. Here I current is flowing. दोनों equal current is flowing. I. And distance is DD. Instead of AB, he has given D and D. I want to net magnetic field at the point P चाहिए.
Sir, 0.
Yeah, 0. Because कितना टाइम current, first current carrying away से magnetic is inwards. Second current carrying away से magnetic is outwards. Same distance है, same current से magnetic will be same. So net magnetic field is B1 minus B2, which is 0. So net magnetic field is B1 minus B2. दोनों same magnetic field आएगा 0. Right? First current carrying away से magnetic field is inwards. Second current carrying away से thumb indicates direction of current outwards. But distance are same, current is same. That's why the magnetic fields are same. Next. करो. Now two current carrying wires are there. One is coming outwards with current I. Other one is going inwards, current I. And distance is A and A. I want to find the magnetic field at this point P, which is root 3A distance के ऊपर. Find करो. Net magnetic field will be because of the two wires. So because this is a perpendicular distance, so this is root 3A, this is A. This distance is how much? And this distance. Pythagoras theorem apply करो. So root of this square plus this square. So 3A square plus A square, 4A square. So 2A. This is also 2A. I want to define net magnetic field because of two current carrying wires. There is a net magnetic field. Okay, so the current is coming outwards. Thumb indicate direction of current and curled fingers indicate direction of magnetic field. Okay, the magnetic field is exactly perpendicular, right? I told right that magnetic field is perpendicular to R. Magnetic field is also perpendicular to DL. Vector form में भी told right. So that's why ये perpendicular distance वाला ले रहे हैं. Similarly, इसका क्या होगा? Is thumb indicate direction of current and curled fingers indicate direction of magnetic field, and this also should be perpendicular. And since distance is same, current is same, the magnetic field will be B and B. दोनों same है magnetic field. I want to find net magnetic field at this point. Vectorial add करो. मतलब if I know the angle between them, then colors. You know angle between them इसका? This is 90. This is देखो. This distance is 2A. Total length. This is 2A. This is 2A. This is equilateral triangle. Angle is 60. If angle is 60, this is 30. And this also 30. Can you tell me this angle is how much?
$60.
No.
Set together.
120.
Oh, together.
30 plus 30.
No. देखो if you
120.
yes, correct, very good. देखो इधर से करो ऐसा total angle is 180, right? So 30 plus 90 is कितना? 110 ना? 120. And remaining will be A60 है. Similarly, इधर से भी total angle किया तो A60 आएगा. 60 plus 60, 120. So now two vectors are connected tail to tail. Complete imaginary parallelogram. The resultant is 1. So B net. This angle is 120. So apply करो parallelogram law. Under root A square plus B square plus A square plus B square plus 2AB. 2AB means B square into cos 120. Cos 120 is minus 1 by 2. So 2 to cancel. Minus B square plus B square cancel. Under root is B only. So B is nothing but mu naught by these are infinite wires, right? So mu naught by 4 pi into I by I is what? I kitna current hai? I is I only by A. A is the distance is 2A. This answer. So since magnetic field is a vector quantity, we have to add vectorially करना पड़ेगा. Like we done force, we studied Coulomb's law में forces, same calculation we are doing. उधर फोर्सेस क्या करता था, वी टू टेल लाइक चार्जेस रिपल, अनलाइक चार्जेस अट्रैक्ट बोल के लगाता था एरोस लगा के. बट हियर वी आर डूइंग करंट कैरिंग वजह से मैग्नेटिक फील्ड वी आर ट्राइंग टू फाइंड बाय यूजिंग राइट हैंड थंब रूल. बढ़िया. वन मोर जेईई मेंस क्वेश्चन को ट्राई करो. क्वेश्चन लंबा रहेगा बट इज टेलिंग टू फाइंड मैग्नेटिक फील्ड एट दिस पॉइंट ओ. द गिवन द टू इनफाइनाइटली लॉन्ग वायर आर बेंड इन द फॉर्म ऑफ 90 डिग्रीज. एक बड़ा इनफाइनाइट वायर है, इट बेंडेड इन द फॉर्म ऑफ 90 डिग्रीज. ऐसे बेंड कर दिया. ए भी इनफाइनाइट वायर से आ रहा है, बेंड कर दिया in such a way that line segment q belong along axis while segment this one parallel to axis. Okay, OP and OQ is 4 centimeters. OP and OQ is 4 centimeters. And the magnitude of magnetic field at O is, net magnetic field also given. Net magnetic field at O they given as 10 power of minus 4 Tesla. Okay, two wires carry equal currents. दोनों equal currents है. मान लो I and I. Okay, the magnitude of current in each wire and the direction of magnetic field at O is. Okay, I want to find current. I चाहिए. So here how many wires are there? How many wires are there here totally? बोलो. Sriram, how many wires are there?
4.
1, 2, 3, 4. 4 wires are there. Bending वाला भी एक cross section. You tell me, anyway tell, is this wire is finite, infinite wire or semi infinite wire of this wire?
Semi.
Semi infinite. Okay. Because of this current carrying wire, what is the magnetic field at this point? Because of this current carrying wire, what is the magnetic field at this point? How much?
Mu naught by 4 pi
No.
into I.
No. This current carrying wire is along the axis of the element. Point is along the axis. So magnetic field is 0. Similarly, this current carrying wire is along the point. Wherever you are trying to find, along the axis only it is there. So इसका वजह से magnetic field is 0. मतलब you left with only 2 wires. This wire and this wire. And this is semi-infinite wire only. And this also semi-infinite wire only. He's trying to find magnetic field at this point. Khatam. So 1, 2, 3, 4 में P1 is equal to P3 is equal to 0. We left with only 1 and 2, 3 and 4, 2 and 4. That's it. So now try. This is semi-infinite wire के वजह से magnetic field find करो. Semi-infinite wire के वजह से magnetic field find करो. And direction if you see inwards, AB inwards है. So net magnetic field will be addition करने का. V1 plus V2. सेमी इनफाइनाइट वर्क का फॉर्मूला यूज करो. श्रीराम, म्यू नॉट बाई 4 पाई इंटू आई बाई distance is 4 centimeters. 4 into 10 power minus 2 plus B2 is mu naught by 4 pi into I by 4 into 10 power minus 2.
20 ampere.
20, yes, correct. Okay, either mu naught by 4 by 10 power minus 7. So कितना होगा 2 into 10 to the power of minus 7 by 4 into 10 power of minus 2 into I. Okay, this is net magnetic field is given as 10 power minus 4. So कितना 4 into 10 power of minus 6 by 2 into 10 power of minus 7. So 2 to the 4, ऊपर गया तो 10, 2 into 10 is 20 ampere. So this much current is flowing in the wires. Yeah. So same concept only, same thing, formulas only. They will ask in different manners. Understood? So straight current carrying wires done. Straight current carrying wires done. Okay, now we have to go for the second shape. कौन सा है? Circular wire. Third shape में you will get the ampere circuit law solenoid में. Okay, उसका applications भी देखेंगे. उसका formula sheet I will also will send. Till now 3 formula sheet आपके पास है ना neatly. And first year का भी formula sheets है आपके पास. Magnetic field at the center of the circular loop. Okay, try करो. How to find? There is a circular loop is there, current carrying loop is there. Current is flowing in this direction. I want to find magnetic field at the center of the circular loop. How to find? Method क्या है? Tell me. Whether we know complete wire का magnetic field, we don't know. But we know only part, a small dl length का magnetic field, right? We can find by dl by using Biot-Savart's law. We're taking the help basis are that one, right? So small dl element I'm taking. I'm cutting a small dl element. That should be along the direction of the current, right? The dl should be along the direction of current always. उसके वजह से इसका distance, इसका radius is a. इसका radius is small a. Now tell me, उसके वजह से what is the magnetic field? Small magnetic field. Tell me. dB is equal to mu naught by 4 pi into I dl sin. Angle is how much? Angle between dl vector and r vector. dl vector and r vector, they are perpendicular, right? So 90 by r square is nothing but a square. So dB is equal to mu naught by 4 pi into I dl by a square. This is a small magnetic field. Okay. Now if I take small, complete magnetic field आने के लिए we have to integrate. So integrate both sides करो. So B is equal to mu naught by 4 pi बाहर आ जाएगा. I by I also will be coming outside. I by a square also coming on. Integral dl रहेगा. Integral dl. And what is meaning of integration dl means dl addition of the complete length is called circumference of a circle. That is 2 pi a. So B is equal to mu naught by 4 pi into I by a square into 2 pi a. So pi cancel, a cancel, 2 cancel. So therefore magnetic field due to circular loop is mu naught by 2 into I by a. This is a formula you have to know. Second shape का first formula mu naught by 2 into I by a. And this is only for one turn, one single coil. Okay. If there are n turns बोले तो n turns है तो सबका magnetic field we should add, right? Okay, that's it. So we are learning only for one coil का length. Okay. Copied. Mu naught by 2 into I by a. देखो, if there are n turns, what is the formula? Like this. If there are n turns are there wires में, सबका n loops का mu naught by 2 into I by a times n number of turns. Sometimes they'll give wantedly. This many turns are there. Okay. चलो, no questions करेंगे based on this. I करो. Just JEE mains question. I'll give options. 1 by n, 1 by n square, n square. One of the two identical conducting wires of length L is bent to form a circular loop. Okay. एक length L है wire. It is bent in the form of a circular loop. Okay, इसका radius है कैपिलर मान लो. A loop in the form of circular loop, and other one into circular coil of n identical turns. Same wire है, same current carrying wire है. इसका length है L है. इसको मैं क्या किया? I bent into many circular forms. ऐसा. इसका radius is small r मान लो. If the same current is passed in both, सेम करंट फ्लो हो रहा है, इसमें आई बोले तो इसमें भी आई करंट इज फ्लोइंग. The ratio of magnetic field at the center of the loop to that of center of the coil. He is asking magnetic field at the center of the loop to the center of the coil is how much? A single loop है वो a number of turns है. So JEE means question.
So 1 by n square.
Okay, देखेंगे. So the question is right. You know the formula for center of the loop, right?
Yes, sir. So I got n square, but I don't know if it's 1 by n square or n square. So I'm checking it again.
देखो इसका फॉर्मूला इज म्यू नॉट बाई 2 इंटू आई बाई कैपलर. इसका फॉर्मूला क्या होगा? म्यू नॉट बाई 2 इंटू आई बाई स्मॉल आर टाइम्स नंबर ऑफ टर्न्स इज एन टर्न्स इसमें. सो म्यू नॉट बाई 2 कैंसिल, सेम करंट इज फ्लोइंग राइट. सो आई कैंसिल. सो क्या होगा? इट इज आर बाई स्मॉल आर बाई, उल्टा हो जाएगा तो आर बाई आर एन इंटू 1 बाई एन राइट, ऐसा रहेगा. नाउ आर एन कैपलर का रिलेशनशिप लेके आएंगे. ये लेंथ वायर है, इट इज बेंड इन द फॉर्म ऑफ सर्कमफ्रेंस राइट. सो लेंथ इज इक्वल टू 2 pi smaller capillary. So therefore capillary is equal to L by 2 pi you got. Similarly, this length is converted to n number of turns. So 2 pi r times of n. So therefore smaller is equal to L by 2 pi n. Now if I substitute here, कितना होगा? L by 2 pi n, L by 2 pi. So L by 2 pi, L by 2 pi cancel. 1 by n into 1 by n, 1 by n square. So you should be very careful questions करने समय. ओके चलो एक एडवांस क्वेश्चन करेंगे. चलो ट्राई करो, देखते हैं किसको आएगा. देखो a long insulated copper wire is closely wound in a spiral of n turns. मतलब ऐसा zoom 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 ऐसा घुमा के लेके आया टर्न को. द स्पाइरल हैज इनर रेडियस इज ए, inner radius is small a and outer radius is small b. Yeah, outer radius is small b. Okay. In xy plane and steady current I is flowing in the wire. So इसमें current I is flowing. Zoom 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 बोल के I is flowing. The Z component of magnetic field at the center of the spiral is. I want to find net magnetic field at the center. Z component means वो Z में आएगा. देखो curl the fingers in direction of current and thumb indicate direction of magnetic field. Z component. So he's telling to find simply magnetic field at center. चलो देखते हैं. देन आपको पक्का फिजिक्स आ गया अभी एक क्वेश्चन किया तो. चलो सेंटर का फॉर्मूला मालूम है ना? करो. Here can we apply formula center में? म्यू नॉट बाई 2 इंटू आई बाई कौन सा यूज करेगा? ए ना बी ना, एंड बीच में रेडियस इज चेंजिंग. हियर रेडियस आई बाई कौन सा यूज कर? रेडियस इज चेंजिंग. विच वन यूट यूज? इफ यू यूज म्यू नॉट बाई 2 इंटू आई बाई ए बोले तो ज्यादा मैडी फील आ जाएगा, आई बाई बी बोले तो कम मैडी फील आएगा, बीच का मैडी फील कैन नॉट बी नोन। सो आपको पूरा कॉइल का लेने का एग्जैक्टली मैडी फील। तो क्या करेंगे? मेरा तो समझ गया होगा क्या करने वाला है। हाँ सादिक बोलो क्या करेंगे? रेडियस इज कंटिन्यूसली चेंजिंग, आई वांट टू फाइंड मैग्नेटिक फील्ड एट सेंटर।
So integrate dr.
इंटीग्रेट डीआर करो, इंटीग्रेशन करो। कैसे करें? अंटिल ट्राई किया था अदरवाइज। सो हम लोग क्या करेंगे, एक रेडियस फिक्स करेंगे, एक रेडियस फिक्स करके उसका स्मॉल मैग्नेटिक फील्ड फाइंड करेंगे, एंड देन वी इंटीग्रेट, यू विल गेट द कंप्लीट मैग्नेटिक फील्ड। ओके, तो मैं क्या करूंगा, सेंटर से स्मॉल आर डिस्टेंस दूर जाके आई विल कट ए स्मॉल कॉइल, एक कॉइल है, आई विल कट ए स्मॉल कॉइल आर डिस्टेंस दूर के, एलिमेंटल कॉइल। ओके, 1 मिनट। सो आर डिस्टेंस जो कट करो ऑयल एंड फाइंड द मैग्नेटिक फील्ड। कॉइल कट किया ना, स्मॉल मैग्नेटिक फील्ड फाइंड करो। हाउ टू फाइंड स्मॉल मैग्नेटिक फील्ड? सो स्मॉल मैग्नेटिक फील्ड, सी मैं इधर से मैं इधर ड्रॉ कर रहा हूँ, दिस इज ए कॉइल कट किया ना, इधर से आर डिस्टेंस दूर के, इधर स्मॉल डी आर है, डी आर इज द थिकनेस ऑफ द कॉइल, डी आर इज द थिकनेस ऑफ द कॉइल। नाउ टेल मी स्मॉल मैग्नेटिक फील्ड कितना होगा? स्मॉल डी बी इज म्यू नॉट बाई 2 इंटू आई बाई आर, म्यू नॉट बाई 2 इंटू आई बाई आर, ओके, इंटू नंबर ऑफ टर्न्स, बिकॉज उस कॉइल में नंबर ऑफ टर्न्स नहीं मालूम ना, ये समझ में आया तक? See, I took a coil. Coil में number of turns we don't know, and small magnetic field is mu naught by 2 into I by R is for one coil into number of turns. वो number of turns find करने वाला भी. Then आपको small magnetic field आएगा. We'll integrate from A to B. We'll get total magnetic field. Okay. Now see कैसे करेंगे देखो. Total turns is how much? This length is how much? B minus A.
Yeah, B minus.
This length is B minus A. Now tell me, n turns has thickness of B minus A. One turn will have thickness of, ठीक है, वन लेंथ ले लो, एक काम करेंगे, B minus A लेंथ का, B minus A लेंथ का, how many turns are there? N turns are there. 1 unit लेंथ का, N by B minus A turns. Okay. Now how much turns है, how much length का चाहिए, हम thickness चाहिए, how much thickness का चाहिए, we want dr thickness का चाहिए, dr की thickness में कितना turns है, dr thickness में n by b minus a into dr turns है, इधर सब्स्टिट्यूट करो, db is equal to mu naught by 2 into I by r into n by B minus A times dr. Is that understood? So R thickness जाके we cut a small coil. उस coil में number of turns we don't know. We applied a formula, but number of turns we found by this method. Unitary method से we got like this. B minus A thickness में n turns है, 1 unit length में one thickness में this much, dr thickness में n by B minus A dr. Okay. Now we got this one. Now substitute. Now integrate both sides from A to B. Integrate करो. एक और बेटा.
So mu
हाँ.
naught by 2 into I log B by A into N by B minus A.
Very good. Okay. So मैं integrate both sides कर रहा हूँ. निकाल रहा हूँ. एक और भी right. So integrate किया तो B is equal to integral A to B mu naught by 2 into I by R into N by B minus A dr. So everything will be coming outside, only dr by R रहेगा. So B is equal to mu naught by 2 into I N by B minus A. Integral 1 by R dr is log R to the base C from A to B. So क्या होगा? B is equal to mu naught by 2 into I N by B minus A into log B by log A. Log A minus log B is log B, A by B, right? Is answer. So आपको इंटीग्रेशन कहानी देखना पड़ेगा. इंटीग्रेशन डर गया तो प्रॉब्लम हो जाएगा. और देखो फॉर्मुलास आर इजी. नाउ सर्कुलर का एक म्यू नॉट बाय 2 into I by R, I by A we learn, right? Similarly, can you tell me for semi circular loop? फाइंड करो सेमी सर्कुलर लूप का. इंटीग्रेशन करना सीखो थोड़ा. सेमी सर्कल की वजह से, सेंटर में वो की वजह से, R डिस्टेंस दूर में, I want to find the magnetic field. I want to find the magnetic field at this point. How to do? Same कहानी. Small dl के वजह से we found, then integrate, we'll get the things. So देखो, I'll cut a small dl length, which is should be in the direction of current only, and this distance is A. So dB is equal to mu naught by 4 pi into I dl sin 90 by A square. समझ. हाँ. नाउ आपको टोटल मैग्नेटिक फील्ड चाहिए. टोटल मैग्नेटिक फील्ड के लिए आपको क्या करेंगे? इंटीग्रेट करने का. सो B इज इक्वल टू म्यू नॉट बाई 4 पाई इंटू I बाई A स्क्वायर बाहर आ जाएगा. इंटीग्रल DL. व्हाट इज DL? DL सेमी सर्कुलर का, सेमी सर्कल, राइट? सो 2 pi R by 2 is pi R, right? So mu naught by 4 pi into I by A square into pi A. So pi पे cancel, A cancel. So therefore आपको कैसे लिखेगा? B is equal to mu naught by 2 into I by A times 1 by 2. ऐसा लिखो, इजी हो जाएगा. नाउ आपको इजी है. सर्किल का फॉर्मूला आता है ना, बाई 2 करो, खत्म. म्यू नॉट बाई 2 इंटू I by A इंटू 1 by 2, बिकॉज सेमी सर्किल है ना. सर्किल है तो I by A, मतलब बाई 2 करने का. तो टेल मी क्वाड्रेंट का फॉर्मूला कितना होगा? क्वाड्रेंट का फॉर्मूला म्यू नॉट बाई 2 इंटू I by A इंटू 1 by 1. क्वाड्रेंट इज हाउ मेनी सर्कल्स? 1 by 4, खत्म. तो देयरफॉर आपका क्वाड्रेंट का सेमी सर्किल फॉर्मूला है ना, क्वाड्रेंट का फॉर्मूला इज, मतलब ऐसे है तो so B is mu naught by 2 into I by A times 1 by 4. This is a quadrant. Now एक जनरल आर्क का भी फॉर्मूला लिख लो, हो जाएगा. डन राइट. सर्किल का बेस ओनली वी आर डूइंग. नाउ जनरल आर्क का, जनरल आर्क कैन बी एनी एंगल. देखो, दिस इज जनरल आर्क. ओके, सेंटर वो में, this is theta angle and this is A, this is A, and current carrying wire is I. Okay, now इसका आर्क लेंथ है L, मान लो आर्क लेंथ L. ओके, मुझे करंट कैरिंग की वजह से आई वांट टू फाइंड मैग्नेटिक फील्ड एट दिस पॉइंट. वो करंट कैरिंग की वजह से. हाँ, नो कैसे फाइंड करेंगे करंट कैरिंग की वजह से? सो आपको सेम इंटीग्रेशन कहानी करके, इंटीग्रेट करके, after solving we'll get the answer. The final answer will write B due to general arc. General arc is mu naught by, same way ऐसे लिखेंगे, mu naught by 2 into I by A, mu naught by 2 into I by A into theta by 2 pi. This is general arc. Suppose we don't know the semicircular, some other angle, it can be anything. We have to use this formula, mu naught by 2 into I by A into theta by 2 pi, and theta should be in radians. Theta should be in radians. Always. You know how to convert radians, right? That's one. तो अभी क्या करने वाला है नेक्स्ट में, सिंस यू नो सर्किल एंड स्ट्रेट वायर्स का ऑल मिक्सिंग टुगेदर पूरा करने वाला है, पूरा क्वेश्चंस पूरा करके, देन वी हैव टू एंटर इनटू द थर्ड शेप, सोलेनॉइड का एंटर होने का. इन दैट में ओनली एम्पियर सर्क्यूट लॉ विल बी कमिंग. उसमें हॉलो सिलेंडर, सॉलिड सिलेंडर, सबका एप्लीकेशंस आर देयर.